Organic Chemistry Lab, Section 12. My name is Ali Claire Ariel.
And my name is Tess Kale.
I'm Avery Younghans.
I'm Jessica Odenwood.
And I'm Ashton Hazelden.
So the objective for today's lab is to calculate the concentration of red dye 40 in our unknown solution, and the unknown solution that we chose for our lab is vitamin water.
The materials for today's experiment are we have 6 cups for our different ratios of our vitamin water and our water. We have 2 measuring cups to measure it each out, and one's for red 40 and one's for water to prevent contamination. And the ticks are on the side to make sure that the ratio amount is consistent each time. Then of course we have our actual unknown solution, which is vitamin water, and then our water itself. And then we have our homemade spectrophotometer, and it's made out of a cardboard box, which we cut holes and also a front and back so that the cup can be seen through it, like so. And then on the back, we have green paper so that when using the coloring app on our phone, it can absorb the red. And then finally, what's not pictured is we'll be using Excel spreadsheet to actually calculate our data and find the concentration and absorbance values.
We already have the stock solutions prepared, so this is our blank right here. It's just water, and then we have 100% of the vitamin A water right here.
And then we're also going to be showing you guys how to prepare all of these solutions in the middle. So just for time's sake, we're just going to be showing this one. But to make this solution, I'm going to be pouring vitamin water to the first tick line, and then she's going to be pouring water to the fourth tick line. So that'll create a 4-to-1 ratio for this one. So first, I'm going to add in to the first tick, vitamin water.
And then I'm going to add in to the fourth tick, just regular water, which will dilute it to 20%.
As you can see, this is our most concentrated solution with stock. It's 100% stock, and this one is 0% stock.
So we're using the colorimeter app today, and we're just measuring at this number right here, how much green is passing through the spectrophotometer.
Okay. So the water solution is just our blank. We'll blank between each to ensure accuracy. Okay, and that number right there is 147. We'll do the 20%. And that number is 112. I guess just to make sure it's like aligned.
Here our value was 64.
Do I blank it? Yeah, 103. Okay, 69.
Here is our data from our Red 40 lab experiment. So this first table illustrates our sample percent and green value data table. The sample percent represents the amount of stock solution, which for us was our vitamin water dragon fruit C drink, in each solution, and the green value represents the variable I, which was determined experimentally using our homemade spectrophotometer. This second table represents our concentration in micromolars and absorbance data table. We found both of these values are X and Y values using the formulas given in the lab instructions. The first formula was used for concentration in micromolar, which was determined using the formula M1V1 equals M2V2. And here is an example concentration, which we found that M2 is 18.8 micromolars for when there's 20 milliliters of stock solution in the sample. The formula for absorbance is A equals log base 10 I naught over I. I naught is our initial green value with no stock solution in the sample, which is 147, and then the I is any of the values here that we were determining. An example calculation is that at 18.8 micromolars, the absorbance was found to be approximately 0.118. Finally, our absorbance versus concentration graph, which we derived from this exact data table, illustrated a positive relationship between concentration and absorbance. In other words, as concentration increased, absorbance increased. This graph also gave us our trend line, which is y equals 0.004x plus 0.0004. And to determine the unknown concentration from this trend line, we used absorbance equals 0.004c plus 0.0004, which again was derived from our trend line. The unknown concentration example calculation at 100% concentration, we found that our unknown concentration of red 40 in the vitamin water was approximately 97.2 micromolars. And this was just found by plugging in those values from the graph.